Today's webinar is an introduction to SOLIDWORKS CAM Standard, and just a little bit about myself. I'm a mechanical engineer with over 25 years experience in CAD, and I've got 20 years experience with SOLIDWORKS and other various CAM packages. Moving into the content, the agenda for today. First off, we'll have a look at the licensing of the product, and then we'll move on to have a look at some of the functionality that's included in SOLIDWORKS CAM Standard. We'll take a look at some of the user interface elements which are common inside SOLIDWORKS, so what you'll be looking at most of the time. We'll take a look at the processes that are involved and that we need to work through in SOLIDWORKS CAM to generate our machine code output. And then we'll take a look at that output in terms of simulation and the G code that we get. And then we'll talk a little bit about post processes just to finish off the presentation. So let's start off with the licensing overview, and I'll just wait for everyone to see that come up on their screens. So SOLIDWORKS CAM Standard is available with every full suite of SOLIDWORKS, that is Standard, Professional and Premium. So pretty much everyone's got it. The only exceptions to that would be as if you had an OEM package, or if you've got a home use license which is attached to an SNL license, as they only provide core functionality and CAM's not included in that. There's no requirement for a serial number. You might see that when you go to install SOLIDWORKS. That's only for SOLIDWORKS CAM Pro, and that's we're not providing that in our region at this time. So yeah, you shouldn't need to pop your serial number into the installation manager when you install SOLIDWORKS. The other thing that you'll need to have a look at is when you install it, if you don't see any sign of SOLIDWORKS CAM in the user interface, you might need to just check your add-ins and make sure that it is in fact added into SOLIDWORKS. Okay, moving on to the functionality. Just wait till that comes up. Looks like everyone's got that. SOLIDWORKS CAM Standard uses automatic feature recognition, which is similar to FeatureWorks, to identify the features which require machining. The algorithms that are used are similar to FeatureWorks, but it's slightly better at recognizing, so that's a bonus. We can also do interactive feature recognition. It's the equivalent manual method of defining features for machining, but for today we'll just focus on the automatic feature recognition. We also have rules or knowledge-based machining, so that gives you an opportunity in SOLIDWORKS to set up the way that the machine process is applied to those features in a technology database. So yeah, it's either called rules or knowledge-based machining. There's also tolerance-based machining, and this is based on the tolerances that might be applied in the model. So if you use DIM expert tolerancing, or if you apply surface finish detail to the model, then SOLIDWORKS can use those details to set up that tolerance-based machining. We won't actually cover that today. That's probably a topic for another webinar. We have toolpath simulation, so once we've generated our toolpaths, we can simulate that inside SOLIDWORKS and see how that toolpath is applied to the model geometry. And then once we've had a look at that simulation process, we then can output that to an NC editor, and we can look at the actual code and modify it in the editor. And there are some other features that we'll have a look at a bit later to do with that. One other thing I'll just mention quickly is that there are some tutorials that are provided inside SOLIDWORKS. So if I just quickly switch over to SOLIDWORKS now, and go into the Help menu, SOLIDWORKS CAM, and look under Tutorials. Just click on that. That'll open up a Windows Explorer window, and there are a number of PDFs listed there, which will guide you through the tutorials. Probably the most relevant one here for SOLIDWORKS CAM Standard will be the mill tutorial. Assemblies and turn tutorials are really only applicable for SOLIDWORKS CAM Professional, so you can probably ignore those for the time being. Okay, coming back to the PowerPoint. What we'll have a look at now is some of the user interface details for SOLIDWORKS CAM. And probably the three main things that, or four main things that come up: the SOLIDWORKS CAM tab on the Command Manager. So there's a new tab that will be added when you've got the add-in active. And there are three new tabs in the Feature Manager design tree. So those are the CAM feature tree, the CAM operation tree, and the CAM tools tree. And we'll have a look at those in a little bit more detail now. First up, the Command Manager tab. It's set out in order of use for most of the tools you'll use. So on the left hand side there you'll see Define Machine, you'll see Coordinate System and Stock Manager, and then Setup. So usually those four things or four processes you'll go through, and then following that you'll go through extracting machinable features, generating an operation plan, generating toolpath and simulating the toolpath, and then post-processing. So they are laid out in a fairly succinct order there in terms of what the process is required. Okay, so the other thing about that ribbon is that it is quite long, and it will wrap around if not all the tools fit on the screen. You'll see here in the picture that there's a double arrow on the right hand side. That was the extent of my screen. There are a number of options that will appear if you click on that double arrow off to the right hand side there. I think if you're using a higher resolution monitor, you may be able to get more of those icons to fit, but it is a pretty full toolbar. Alright, moving on to the Feature Manager tabs. At the top of the first tab here, which is the Feature Tree tab, you'll see the SOLIDWORKS CAM NC Manager. That's on all three of the tabs. Below that, you'll see that there's definition for the machine, the stock, the coordinate system, and then there's a mill part setup icon there, and then right at the bottom we've got a recycle bin. One thing to note there in particular is that for the machine definition, we've got metric associated with that, and I'll talk a little bit more about that when we get into the processes. So just keep that in mind. if we take a look at, so that's the first tab, which is this one here. If we move to the second tab, which is the operations tree, you'll notice that you've got the same icons towards the top there, but under the mill part setup, what we'll see here is the actual operations. So if I just go back to the previous slide, what we see under the mill part setup here is actually the recognized feature list. Okay, so these are the recognized features. There's a face feature, perimeter open pocket, irregular pockets, etc. If I switch back to the operations tree, you'll see that it now shows the operations. If you wanted to take note, you would also, or expand those operations, you would see that the features are actually absorbed in under the operations in that tree. The third tab along is the SOLIDWORKS CAM Tools tree. And this only shows the machine at the top there. It doesn't have stock, etc. And below that, it just gives us the definition of the tool crib, which is being currently selected for that machine. And under the node for the tool crib, we see all of the various tools which are listed for that particular tool crib. You can change the tools here by editing the definitions. Alright, so let's take a look at some of the processes involved in using SOLIDWORKS CAM Standard. And on the list on the left-hand side, I've sort of narrowed down what we'll have a look at today, and that is looking at the definition of the machine, setting the coordinate system, setting the stock definition, defining the mill setup, extracting the machinable features, and then we'll generate the operation plan and the tool path, and then we will post-process that tool path to generate the G-code, and then take a look at that G-code in the NC editor and look at the backplotting of that. And you can see on the right hand side there a flow chart of the usual processes that you'll go through. You will notice where we've got definable machinable features that we've got automatic feature recognition or interactive feature recognition listed in that one, because we can do both at that stage. And I think what we'll do now is switch over to SOLIDWORKS. And what I'm going to do here is just open up an example part file that I've got prepared. So I'm just going to go File, Open, and I'm just going to jump to this predefined part. One thing to take note of when working with SOLIDWORKS CAM Standard, and pretty much any CAM package really, is that SOLIDWORKS, usually by its definition, if we look at the top view, actually let's just go for the top view. If we look at the top view, that actually isn't going to give us the view we need to do the machining. And typically SOLIDWORKS top view is aligned so that if we're looking normal to the top plane or the top view, it's in the Y direction. In most machining operations, Z is usually in the top. So what I'm going to do is just go to my isometric view, And of course, that's still got the top plane there. But if I want to shift to look so that we're in an ISO Z view, I'm just going to mouse over the X-axis on the triad in the bottom left-hand corner of the graphics interface. Hold down my Shift key and click on the X-axis and rotate the model around. And that's, you can do that with any SOLIDWORKS model. It doesn't really have to apply to SOLIDWORKS CAM. It's just a quick trick to get things into a good orientation for SOLIDWORKS CAM. This is a CAM tutorial part. These are installed on your system with SOLIDWORKS into a specific location. So if I just take a look at my C drive and go to my users folder and go into my public folder and documents, SOLIDWORKS 2018, CAM examples and tutorial parts, and then mill. That's where all of these components are listed if you want to practice with the tutorials. Okay, and they are installed by default with SOLIDWORKS. Okay. So let's go to the CAM feature tree first. You can use these navigation arrows on the feature tree to scroll over if you want to keep your feature manager design tree window to a minimum size, or obviously you can drag this out and get access to all of the tabs. So I'm just going to click on the SOLIDWORKS CAM feature tree here. And because we haven't started working with this with SOLIDWORKS CAM, all we can see here is just the standard icons there. Currently, we don't have a mill machine set up for this particular part. So first off, I'm just going to look at the define machine. I can either click on the button in the top left-hand corner here, or I can right-click on the machine here and go to Edit Definition. And this will take us into the machine definition, and this is typically used to specify various things like the type of machine that we're using here. We can specify the tool crib to be used with that machine. We can specify the type of processor that we're going to use, and also some other things, but we'll just stick with those for the moment because that's the basics. One thing that you should be aware of in SOLIDWORKS CAM Standard is that when you make a selection here, if you want to make it change, you actually need to click on the select button to action that change. So if I was going to go into post processor, for instance, and I wanted to select a different post, let's scroll through the list and look for a generic FANUC. If I wanted to make that change, you'll notice that the active post processor is listed as the M3 axis tutorial.ctl. I'd have to click on select here to make that the active post processor. If you merely select it in the list and then press OK, it won't change that post to the one that you've selected in the list. Okay, so something to be aware of. Same here, if you change the tool crib, you've got to click on the select button to activate that selection, and also the same in here. One thing I also mentioned earlier was that the mill machine had metric alongside it in the feature manager there. That unit type is actually specified based on what the SOLIDWORKS file is listed at. So if I was to change my units to inches, pounds, and seconds, when I go into edit the definition of my machine, you'll see that the mill has changed to inch now, and SolidCAM automatically picks up that change for you. I'm just going to change that back to millimeters, grams, seconds for now. And you'll notice that that's gone back to metric again. If I edit the definition one more time, that will also show as metric. Okay. So I'm just going to close that off. Is anyone having issues seeing that come up on the screen? Okay, looks like everybody's okay for now. All right, so the next thing, let me just, okay. All right, so the next thing that we want to have a look at here is the stock manager. So I'm just going to right click on that and then go edit definition. I could also access it from the toolbar as well. What we can set here is the stock size or the material that we want to cut away to create our end product, which is the model. There are a number of different ways we can do that. By selecting different stock types. So in this particular instance, this is set to use the bounding box. We can use various different coordinate systems that might be set up within SOLIDWORKS. So in this case, it's just going straight from the origin. What that means is that our bounding box will be offset based on the origin that's picked here. So we can use the bounding box offset details to offset the size. So if I just start adding material, you'll see that increase in the X direction there. I'm not going to add any extra material at this stage. The other options that we've got here is that we can use an extruded sketch to specify. You'll notice if I change that, you get some different options here. We can also use an STL file, so we can import an STL and use that as the basis for our a stock. So it might be a casting or something that someone else has designed in a different system. And then the fourth option that we've got here is to use a part file. So we could use the selected model, and we could specify a configuration of that part file, which may be predefined as the stock size. So a number of different options, and it's quite flexible in the way that you can define that stock to cut away from. The other thing here is that you can specify material. So there are various different types of materials you can specify. I'm not going to make any changes here, so I'm just going to cancel out of that. There's also an option here to specify a coordinate system. Now, what this refers to is different to the coordinate system that we've just looked at that's in the stock manager. The coordinate system in the stock manager just gives the stock a reference to change from. But what this coordinate system does is it sets up the coordinates for the part with reference to the machine. So we could use an entity to specify that. So we could pick a vertex or an edge or something like that. And then there is some axis definitions that we can set up as well. We could use the part bounding box vertex. So if I select that option, what that does is it gives us a number of vertices that we can select on the screen, and they're highlighted as white spheres. Okay, so you'll see there's a number of them. And if I click on one of those, I can use that to re-specify that coordinate system. We can also use the stock bounding box vertex. Okay, so that first one was the part bounding box. You can also use stock bounding box. In this case, there's not a lot of difference, but it gives you a number of nodes that you can pick to set that coordinate system for the component. I'm going to leave that how it was. It doesn't have to be defined. If you don't define that, it's not a great big issue. SOLIDWORKS and CAM will work out where it needs to be in space based on the original coordinate system in SOLIDWORKS. The final thing to do here is to set up a mill setup. And we can actually skip that step and just go straight to extract machinable features. If we were to do this, basically what it's looking for here is a plane to work from. So we could select the top plane here, for instance. If you do this manually, what you'll notice is that it gives us an icon and it indicates the direction of the travel of the tool towards the job. So what this is suggesting here is that the tool will come down towards the face that I've selected for machining of that particular body. I'm just going to cancel out of that at this stage and go straight to extract machinable features. And this is where we start to build the details of what to machine. So unfortunately, when that occurred there, what we should have seen was the message window. So if I just bring that up again and drag that across, it actually appeared on my other screen. You'll see that it's gone through that process there. You will see this CAM message window pop up from time to time. You can close it, you don't need to have it open. And you can also clear any messages that do pop up there. You can pin it to the screen so that it's always open, or you can close it and it will pop up whenever you do some processing on the part. One thing I'll just point out here is that obviously it's gone through and identified a number of features. Okay, so if I just click on those features, it'll show me the various pockets that it's picked up. The way that it identifies those features is actually set in the options. So if we go to SOLIDWORKS CAM options and look at mill features, you'll see that there's a section here on feature types, and we've got holes, non-holes, boss, face, and part perimeter selected. So when we do the automatic feature recognition, it will actually go through and look for those particular types of features. You'll also notice in the feature tree on the left that there's a hole group that's been specified. There'll be a number of holes listed under that. I'll show you that shortly. We've got an option here to create feature groups. So whenever it recognizes features that are similar, it will populate those into a group. I'm just going to cancel out of that. And if I expand that whole group, you'll see that it's identified those same 5 hole features. Okay, so it does collate those holes into a group. Okay, so once we've got our features identified, we need to then generate an operation plan. So if I switch to my operation tree, right now you'll see the mill part setup is there, but there are no operations listed. So I'm just going to go ahead and click on the generate operation plan. SOLIDWORKS CAM message window pops up and it shows the progress there. And you'll see that it generates a number of operations related to the geometry. And if we expand the node of those operations, we'll see the associated geometry or feature that's been identified listed underneath the operation there. We do have the option to sort operations. So what it's done here is it's just shown rough contour, rough contour, etc. That may not be the way we actually want to apply that in terms of machining. So we can actually go into sort operations and we can sort by various types. And so if I click apply here, you'll see that the sort order changes in the feature manager design tree. So it's put most of the roughing at the top. There is a contour, which is just the contour around the outside of the size of the block there. It's put some drill operations at the top. I may not want those there. I might actually want to do those last. So we can also sort these operations by just dragging and dropping. So I can just grab hold of that center drill operation there and drag it down to the bottom, and it will reposition or sort that towards the bottom of the tree there. You will notice on these drill operations that there's a little warning there. If I right click on that warning and go to what's wrong, it tells us what that error is, and in this case the tool selected was not from the tool crib. So what we can do is we could go in and add that tool into the crib that we've currently got selected. For now, I'm just going to clear that error. When I click on clear, you'll see it removes that warning from that icon there. And I'm just going to do the same for the other icon here. So I'm just going to clear that one off. And now that we've got our operations specified, assuming that we're happy with those, where they've been applied, what we need to do is generate the actual toolpath. So at this stage, it's gone ahead and created those operations. If we wanted to edit the definition, we can right click and go in and take a look at how those operations have been defined. This is a roughing operation, so we can go in and say what sort of strategy we want to use to make that cut. These predefined strategies that it's using are coming from the technology database. Okay, so I'm just going to leave that one as it is for now and just go ahead and create that toolpath. In fact, let's just select that and go generate toolpath. It will actually go through and process all of those toolpaths, and when I drag my mouse over one of those operations, it will highlight the toolpath in the graphics area for me. You'll note that one of the operations there is still shown in blue. When it's in blue, that means that the operation's been created, but it doesn't have a toolpath. So if I mouse over that one, no toolpath is shown. The reason that that is still blue is that SOLIDWORKS CAM Standard has identified that that toolpath is probably overkill. It's not actually necessary to machine that because it's been machined in some other operation, so it's kind of surplus to our requirements. What we can do with that is we can just right click and go delete. It'll tell us that it's going to delete any dependent items. That's fine at this stage. I'm just going to click yes, and you'll see that get moved into the recycle bin. It doesn't remove it completely from the operations list in terms of being available. If I decided at some other time that I needed to use that again, then I could restore it. If you choose to remove it, that is when the removal becomes permanent, and you can't retrieve it once you've removed it from the recycle bin. But it's nice that it doesn't remove it completely in the first instance, that you can actually retrieve that if you do need it later on. Once we've got our toolpaths generated, the next step would be to actually simulate. So I'm just going to click on our Simulate Toolpath button, and that takes us into the simulation of the toolpath. There are a couple of different ways we can work with this tool. By default, it usually goes into tool mode, and that allows us to step through and look at the tool, the way the tool is moving as it's following the tool paths. That can be helpful if we're trying to avoid collision with other things in the model. There's also a turbo mode as well, and if I select that one and just click run, what that does is it pretty much takes us to the end of the toolpath. You don't get a great deal of simulation as such with that. So I'm just going to go back to the start now and select tool mode again. There are a number of options that you can specify within this simulation dialog, so we can show the difference between what's been machined and what was originally there. We can take sections through it. We can change the way that the stock is displayed in the model, so we can choose not to display it or use other various options depending on how we want to look at it. We can also do that with the tool and the tool holder as well. And then within the actual options for the simulation, we can identify some different ways of looking at collisions. We can also save the work in progress as an STL, so we can bring that back in if we want to use that as stock, which is a really handy option if you're doing multiple operations. And we can also choose to show some XYZ color coordinates in there if we want to look at that while we're simulating. So I'm just going to run that. That's obviously moving fairly fast. We can adjust the speed here. Sometimes it's better to have it a little bit slower so we can see what's going on. Okay, we can see it stepping down into that corner there. I don't know how well that's going to be showing up on your screens, but hopefully you'll get the idea. Obviously, if you don't, probably be worth getting the downloaded video and taking a look at that afterwards just to see how that works. I'm just going to ramp the speed up there so that it takes us to the end, and you can see now the end product. Just wait for the audience view to catch up there. Looks like most people can see that now. So once we're happy with that simulation, that it's doing all the operations we need it to do, we can click OK. There are some additional operations in here for stepping through the toolpath and saving out a CL or a cut a line file path. I'm not going to cover those today, but what we will do is go to the post-process operation. And when we click on that, it's going to ask us to save that file out. It usually comes out as a text file, but you can specify various other file types. So one of the most typical ones that I see is an NC code file type. So I'm just going to export as .nc and save. In the post-process dialog, at this point in time, we have the toolpaths in SOLIDWORKS CAM Standard, but it hasn't actually created the NC code. So I'm just going to click play there. And what it does is it goes through and creates that code based on our post-processor. Once we've done that, that's really great. We can actually scroll through that and take a look at all of that code. But ideally what we want to do is have a look at that in an editor. And with SOLIDWORKS CAM Standard, we get the SOLIDWORKS CAM NC editor provided. And when we click OK on the post-process window, that will open up the NC editor, which is just opened up on my other screen. So I'm going to drag that across for you. And basically what we can see here is the raw NC code that's been output. There is a little bit of color coding that goes on there, so various different operations. So G00 is shown in red there, and also some of our rapid moves, etc. You can set that color coding if we go to the editor and go to global setup and look under colors. You can change your coloring in those options there, and it will list what the various ones are there. So G2 for counterclockwise arcs, etc. Probably the most important thing that I find in the NC editor though is the backplotting. And if I launch the backplot window, what it'll do is give us a graphical interface view of what's actually happening in the NC code. So if I just go back to the start here and click on the play button in the backplot window, you can actually see it backplot the code and generate and see the G code that's associated with that. Now that was pretty fast, and probably most of you won't have caught up with what's going on there yet. I'll just give it some time to catch up. But basically, I've always found it fairly useful to go through this process to identify if there are any issues prior to exporting this out to a manufacturing machine. As most people would have probably been tripped up with some NC codes somewhere along the line, and this really just gives you a safety net between taking it out of SOLIDWORKS and the machine, putting it out to the machine to make sure that the code is actually going where you expect it to go. Okay. One other thing I just want to mention, so I'm just going to close two things actually. With the NC editor, this won't open as a standalone program. You must initialize this from SOLIDWORKS, as I've just done through the code editor options. You can't launch this by itself. You'll see an error message pop up if you try to do so. But once you're actually in the editor, you can open other NC programs from here. So you can see I've got some other ones. If I open up that, it'll show me a different sort of code there. So I'll just close that one off. The other thing that I was going to mention there is that the tech database, which drives all of this, so this is the technology database here in SOLIDWORKS. Just wait for everyone's screens to catch up there. So if I just click on the technology database there, it loads up the database. And if I go into the settings for this, you'll see that there's a file location specified for that. If you're going to make any changes to the way the operations work in that database, you should back up this folder location here. So back up the whole folder, not just the database file itself. If you do run into issues with SOLIDWORKS CAM, this will help you recover. Okay, so I'll just point out that at this stage. And we're probably getting close to time, so I'm just going to move on to post processes, just a little bit about those. And just want to mention a couple of things about SOLIDWORKS CAM Standard. They provide a number of generic post processes out of the box. This should cover the majority of the machining operations or scenarios that you'll use for 2.5 axis milling. And at this stage, we're not looking to provide customized post processes. It's simply not really cost effective for 2.5 axis, where most of the posts that SOLIDWORKS CAM does provide are sufficient for those machining operations. All right, so that was fairly quick run through there. That